The surface area of a cone is a little bit different formula and maybe could require a little bit of algebra. The first thing to note is, of course, we have a circular base and we know how to find the area of a circle. That is just pi times the radius squared. But then we have this, lateral area, this part right here, which in a cylinder is just a rectangle that's been kind of curled around, so we can use circumference. Well, this, of course, is less than that. It's a smaller amount of surface area because it's kind of a tapered piece. It would almost look like a triangle, but with a curled bottom that we would kind of fold around to make that lateral vertical area. And the way we can calculate that is pi times the radius times the length of a side. And we call this that length, this part right here. Okay? And then we add those two together. So that's the formula for surface area of a cone. Let's do an example. So here you can see we have a cone with a radius of 10, and that kind of side length, that kind of slant height is 10. So using our formula, we do pi times the radius squared plus pi times the radius times that slant height, like that. So here you can see I've typed that in, pi times 6 squared plus pi times 6 times 10. So this is a good formula to know, or at least just, know how to manipulate. The one thing to maybe just know about this formula, because it's a little less intuitive than maybe the cylinder, is this kind of added on part right here is, again, just kind of a manipulation of circumference that, when we created this little kind of thing like this that we could fold around to make the bottom, this part right down here wasn't the entire circumference. So it's a manipulation of what portion of the circumference did we need to be able to build, kind of that base part of our lateral area. Let me show you one other example where we got to do just a little bit of algebra before we can use our formula. So let's say that we were given, first of all, I just wanted to, as I always do with problems like this, point out that I gave you the diameter. Well, obviously, our formula is not a function of the diameter, it's the radius. So we should just note that our radius is 5, half of that diameter. But I also didn't give you the that side height that goes right here. And that's what the formula requires. It's kind of that slant height. I gave you the height of the cone. But we can easily find the height of the cone knowing that we've created a right triangle inside of our cone, like this. And we can use Pythagorean theorem. So let's use Pythagorean theorem to figure out the length of that slant height. That's our hypotenuse. So we're going to say leg squared plus leg squared equals that slant height squared. So 25 plus 144 equals that slant height. I suppose maybe I should make it not look quite so much like a 1. I'll make it like a cursive L. Okay? So 169 equals that slant height squared. Square root of 169 is 13. So this is 13 right here. So if you have the height of the cone, that's not part of the formula. The slant height, that side length height, is what we need. You got to find it. But easy enough with Pythagorean theorem to do that. So our formula would be pi times our radius squared plus pi times the radius times that slant height. You see I've typed that in. So again, a good formula to know. Maybe not necessarily needed to memorize. You could maybe look this up very easily. But remember that it's different in that it doesn't require the height of the cone like most of our formulas. Rather, it needs the height of that side. If this video helped you, please like and subscribe for more math help.